All right, hello everyone. January 20th. All right, it's very late today. I hurt my knee. Damn. I know the training I was pushing. I know I was pushing a little bit hard this week, and then today feels okay. Okay. And then I hit a, and I was moderately heavy clean and jerk, which is exactly the same weight I hit every single day, and it was okay every day. And afterwards, I felt and every day at my current shape, I always hurt. The knees always hurt at the end of every session. So I was like, okay. And then after that lift, I feel the same way. And then I sit down. Yeah, I feel something is wrong inside. And I was like, okay, I'm gonna hit one more. Bend down at my starting position. Yeah, the knee just it's screaming. So I basically call it quit. I was like, no, I'm not doing it anymore. So I thought it's just gonna stop at however I was feeling back there, but it's been getting worse, and it's a little bit swollen, and it's inside. It's different from the other knee issue I got in the past. The other issues, I mean, I used to have patella tendon issues. This is not. This is something inside, which I have been having. Just like slightly pain, but I mean, what I feel right now is um, pain, but also sore, like extreme soreness, and just sore going towards pain. It's not as like a sharp pain compared to the patella tendonitis I used to have, but it's disturbing. I was going to say the technique is getting better and better every single day. So that was good. I feel good. I feel power and speed, but I'm no longer. I can't. I mean, the snatch is feeling good, but the clean and jerk is just getting weak. I just feel weak. I can't squat. I mean, with knees like this, how can I even squat? And I haven't squat decently for a while because not only was my knee hurt, I also have a hip injury, a bit overused. I feel like just a little bit overused. So next week I'm gonna take a deload, like a good deload, and I'm still gonna do some movements, but power only. We're only gonna do power, so not to tax the knee a little, even more. And we're gonna hit like 115, 135, just like that. Man, just getting to this current stage, it's yeah. I think have to start to realize maybe for me, it's the and no more PR is gonna come, but I'm still gonna treat each block. I mean, I was not training well for this block. I feel good because I was pushing for the technique and stuff, but I was not following the program at all. Did not manage my volume. Man, it just you gotta manage your volume, but just I don't like the program. That's what it is. I don't like the program. That's why I don't stick to it. I don't like all the varieties. I just want to snatch and clean jerk every session. Um, it's just the weight. I didn't control it well, so the volume always pretty high, and I guess the knee just can't handle it. Man, we'll see how I feel like tomorrow after a nice sleep. Hopefully, it'll get a little bit less swollen. Ugh, bad. Alright, anyway, let's do this. Let's just do one. I feel tired. Sum of subarray minimums given an array of integers. Oh, by the way, I also don't want to do this one anymore. Which one? This one. Come on, we'll just do this. I don't feel like doing this one anymore because I even if I do it another time or another 10 times, I don't think I can memorize or even come up with that smart solution. It's not possible for me. Oh, I have interview next week and a week after that. Oh, maybe I can do leg raises. Seriously, maybe I can do leg raises. It doesn't hurt as much as doing squat. Huh. We'll see. Alright, let's do this. Give an array of integers. Find the sum of minimum b, where b ranges over every contiguous subarray. B ranges over every contiguous subarray. Find the sum of minimum b. So basically we need all the subarrays and then to find the minimum. Yeah, just find the minimum value of all the subarrays. Right? No, it's not. It is get all the subarrays, find the minimum of all the subarrays, and add them together. That's the one. Holy crap. I saw this long time ago, 907. Oh, I don't even remember this problem at all. 3, 1, 2, 4. So all the subarrays. I don't know. Can we DP this thing? Like, let's say if we find all the sum of the subarray of these. Okay. Now we add a new one. So we need to add all the subarrays that ending at 2. Right? Ending at 2. Okay, so all the subarrays ending at 2. 2 by itself is 2. And then we look to the left and we have something smaller. So its value is going to be determined by hold on. So I have a current value, right? If I look to the left, if this is bigger, then this subarray is using this. If another one bigger, subarray using this, right? If I have something smaller, okay, something smaller. If it's something smaller, that means this subarray will use this. Okay. And once I hit one smaller, then it's always going to use a smaller, right? Maybe it's a monotonic, what, decreasing array? No. Monotonic increasing array. Monotonic increasing array. Therefore, this, like, if this one is smaller than this, then we simply add. So if it's a monotonic increasing array and then current one is small, then we just pop everything in between will use this value, and until we have, like, this one's here, this is smaller. That is the hard part. So if I have something that's smaller than this, then what? Well, I know the sum of all the subarrays ending at here. Okay, I know all the sum ending at here. So if I encounter this, and when I do this, right, and this says all the subarrays ending at this one, no matter what they are, I have the sum. Okay, and I want to calculate the sum of all the subarrays ending at here. And what I know is when I have the situation that all the subarrays ending at this, including this, will be the same as this one, because everything here will be deleted. So it's just the same as this. Monotonic increasing. So the first one is 3, so we record is 3. Next is 1 because it's next is 1, right? And then if any that's bigger, we just pop. and then we have 1, right? And then we have nothing. So anything in between, however many, with the times this 1. So basically, this one is 3, right? This one is 1 because it's 2, so 1 times 2. Now there's 2, okay? 2 comes in, and I cannot pop. So whatever is the same. So this one is going to be 1 time. So this is 2. So this is going to be 2 plus, because it's adding this, 2 plus itself, 2 plus 2. And then the next one is 4. 4 is going to be 4 plus 4. So answer is 3 plus 2 plus 4 plus 8. That is 17. Baby. Okay. I think this one is correct. I can't even write it right now. Use monotonic increasing stack. All right, mod. I can do this, right? I think so. And then we say stack is gonna equal to array 0. Nah. Let's do this. Res is 0, stack for while stack and stack minus 1. We need to put index. Okay, we need to put index in there. So array of this, right? Array of the last index if it's larger. If it's larger or equal to the current one, then stack the pop, right? We can pop everything that's bigger than me into something smaller than me, right? And then what we're gonna do is, well, we will say whatever is. Oh, do we also need? We do need a DP. Oh, okay. So DP gonna be 0 times right? DP is this, and then we are here. Oh, now we need I. Enumerate. Okay. So what we need to do is check the stack. We say if stack, right? Then dpi shall plus equal to dp stack minus 1, right? We need to add everything and everything in between, right? Plus a times I minus stack minus 1, right? Which means if stack, if it's 0, and then you're 3, 1, 2, 3. So 3 minus 0, that is correct. So we do that. Else, if there's nothing, right? If there's nothing else, then dpi plus equal to a times I plus 1. So everything in between. Okay, that's fine. We probably need to mod this thing, so we are going to mod. We'll do this. We'll do this, and then we'll mod, right? And at the end, stack dot append I, right? And res equal to res plus dpi and mod. So we just keep modding, and at the end we'll return res. Okay, we can run 2 tests. First one is 3, 1, 2, 4. Answer is 17. Second is 11, 81, 94, 43, and 3. That one is 444. Oh, good number. So this is gonna be array, and this is gonna be sum this array. Okay, let's take a look. This is 20. Ugh. Okay, look pretty solid. We can actually also do ON. Yeah, it has to be ON. That's where, you know, LeetCode is a little bit easier, because they tell you these constraint. Float or literal 0 cannot be assigned to. Huh? What the hell? Cannot be assigned to. Where does float come from? The mod? Wait, what? Wait, hold on. Wait a second. Wait, what is this? Argument of type float cannot be assigned to value of int. Float is incompatible. Where is float? Which one is float? A is not float. Right? A is not float. Actually, that's something I don't know how to do. How do I type definition, fuzzy search, swap next, inner, open diagnostic list? Set item. What? I don't understand. See, I don't understand. There is no float. I don't know, which one is float? I is not float. Oh, this might be float. This might be float. Okay, let's rewrite this then. Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. You happy? Yep, it's happy now. It's not happy. Alright, let's run this. Probably some typo last time. I use this. Now we learned something new. You can put the index in it. Yeah, it's actually a better solution than last time. Okay, we're done. All right, I said I'm tired, but let's just do one more. Let's just do one more. All right, largest element in an array after merge operations. You're given a 0-indexed array, nums, consisting of positive integers. You can do the following operation on the array any number of times. choose an integer I such that I is inside, okay. Nums I is smaller, okay. Replace the next element with nums I plus 1 and delete the element nums I from the array. Return the value of the largest element that you can possibly obtain in the final array. So basically we need to pick some I, right? We pick some I, and requirement is this index, this value is smaller or equal to the next value. And then we replace the next value with the sum of these two values, and we delete the previous one. Okay, so in this case, if I choose 0, it will become this. I choose 1, which is 7, it will become this. Then I choose 0, will become this. The largest in the final array is 21. Holy guacamole. Says to just choose this. Oh my god. This is an interesting problem. This is very interesting. Piqued my interest. Okay, piqued my interest. So how do we choose? Let's see. So we need to pick a value, which is, and then basically we combine the two into a new value. So the largest possible is if we can combine everybody together, right? Okay, here's what I think. 2 to 3, 3 to 7, 7 to 9, and 3. This is what we have initially, right? And then I can start from, you can start from anywhere. But what if I start from here? I do 7 and 9, that's 16, right? I can do this, that's 19. I can do this, that's 21, and then 3. But how do you prove this is the best option? Well, if you have a chain, you can always add them together because you can go right to left. You can always add them together, right? So all the chains, if you add them together, so you might have a chain, and then you have another chain, and you have another chain, right? In between the chain, you cannot do, because if you can do, that will become a new chain. So basically, this is going up, this is going up, and this is going up. So what you want to do is to add the chains together, then we form a new one, and then you find the chain and add it again. What do you think about this solution? It's feel like greedy, right? It feels like greedy because you are saying that the best strategy. Yeah, it is the best strategy because you can't. Like these two chains, you cannot merge until you finish, because this one is larger than this one. That's why the chain breaks. Okay, so we're gonna go from the front, da 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 da, and then we push a new one. Let's give it a shot until we can't, right? Until we hit something that we haven't. Yes. Okay. So let's give this a shot. We will quit this and copy again. This one is gonna be 9. So we do LeetCode 9. All right. That one I'm actually going to recursive call this, right? So we're gonna say merged has merge. That's gonna be a false. Okay. And then what we're gonna do is next nums. Okay, next nums equal to this. Okay. And then for I in range 1 to len nums. Okay, 1 to len nums. Actually, is that the best way? We add, boom, doesn't work, right? We add, doesn't work. Okay, so we say current, right? So current is 0. Okay, we say if nums I is larger or equal to nums I minus 1. If that's the case, then we say current plus equal to plus equal to whom? Yep, nums 0. And you will always have at least a 0 in it, right? So plus equal to nums I. Okay, plus equal to nums I. Else, the current one is smaller than the previous one. When that happens, next nums, we do next nums dot append current, right? And then current will equal to nums I. We'll reset. Da 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 da. Once we're done, we check if has merged. Actually, every time we do this, right, we say has merged equal to true. Right, we have merged. So if we have merged, then we'll return max array self dot max array next nums. Otherwise, we'll return the maximum of next nums. Okay, something like this. Let's take a look. We have 2 examples again. First one, 2, 3. 2, 3, 7, 9, 3. Second, and also answer is 21. Second one is 5, 3, 3. Answer is 11. Okay, let's take a look. This is nums. This is max nums. Okay, save this. Calm down. This is 89. Max arg is an empty sequence. Oh, yep. I see the problem. The last one, right? The last one, because you don't have anything at the end. Yep. Any subarray that is increasing can always have all the elements summed, and this will break when a non-increasing, when a decreasing, right? When a decreasing pair shows up. Thus, we can break up, right, the array, break up nums into stretches of non-increasing subarrays. We sum each stretch and put them together, right, into a new array, and then run, and then recursively find its result, find its max array value. Now the runtime, so we take O(n) to go through everything, and then we squeeze everything down So like you run once and you have these chunks, and then depending on how many chunks you have, right? And if you don't have too much chunks, then I'm afraid this might this a timeout. No, it won't time out because each time you combine some, combine. So that the first round you run ON, right? And then after this round, you either drastically reduce the number that you have, or you remain have a lot of values, but some and then some. The worst case scenario, each round you have the two. Actually, I don't know the runtime, but I feel this one should be right. Yeah, I actually have no idea on the runtime. Make sure this one works. I just take a look and see if it works. Oh, it doesn't even work. Oh, that was terrible. I thought that was it. I thought that was it. Oh, this is hard now. Now this is different. What's the answer of this one? 781. Ooh-wee. Did you do something wrong? I don't know. Let's print. Let's print nums at every round to just kind of take a look. Okay, basically I add this together, which is yeah, it's 344. Oh, but that's not the right way, right? This is 70. Yes. And then I add these two together, and then I add these together, and then these together, and then these together, and then these together, and then I try to add this together, and then this together, and then we cannot add anymore, so it's 344. But the answer is 781, which means we're breaking, right? We're breaking this rule. This is not the right rule. Holy crap. I mean, so we need to try to build. Oh, I see. You don't do it. You break it. We do this one first, right? And then it's 98. So we just want to be slightly bigger than this. I think I know the, yeah, this, what I was doing was not the right strategy. So let's do this again. So we have 40, 15, 35, 98, 77, 79, 24, 62, 53, 84, 97, 16, 30, 22, and 49. So we have 40. Okay, so the next value of 15 is small. Okay, I hang it around. And then 35. Oh, this had because 50. I think this is a better value. So the first value is larger than this. Okay, and then 98 is already larger. 77. I'm trying to find the next one. That's going to be 156. Add these two together. Okay, 24 plus 62, that's 86. 86 plus this, 139. No, Yes, 139. And 139 plus this is 223. Right? 139. All right, last one. This is going to be 113. 113, 143. 143 is 165. 165 give us 200. 165. 214. 165. Oh, and then I can add these together, right? So that's a 90. That's 188. 188, 340, 344. 344. That's still not right? 344, unless I made the calculation wrong. Because that's only 567. That's not what we're looking for. 40, 50, 98, 156, and 223. 567, yes, that's correct. That's not what we want. Unless I got something wrong. 50, 98, 77, 79, 156, 24, 62, 86. I just realized I cannot keep adding. So this is, this is still right. Here is not right. Oh, and also have these. Damn it. Hold on. Right, so we have 24. Okay, which is smaller, and then we try to add 62, which gave us 86. But this is small, so I cannot, so it's going to be 86. Now we have 53. It's smaller, but 53 add to 84. 137. Okay, next one's 97. Okay, this has to be by itself. Next is 16 because it's small. Next is 30. Next is 22 plus 49. Give us 71. Okay, so that's the first round. Second round. Second round. You add these together. Yeah, because 40. That was big. This, and this is small. No, you try to add this, so next one is 40, 50, 98, 156. And so you can add them together, and then the next one should be 86 plus 137 will give us 223. So try to, so 223. And next 97 doesn't work. 16. Oh yeah, next one will be 97. Right? And then 16, 30. Why 16, 30? Because your rule 16 should be plus 30. There should be 46, right? This should be 46. And then this now is 46 plus 71. So try to beat, oh, we can beat 197. So we beat it. And then the next round is this, right? I guess this one is good. And then 97, so we have 97 plus this. We have 214 here. So still cannot beat. So we're gonna add these together. Which, isn't that the same as before? 8, 156, 223. Yeah, It's still 567. I was correct. So this one doesn't work. Huh. Yo. Oh, man. Maybe we have to DP this thing. I thought we don't need to DP. So if we DP this thing, how do we DP this thing? In the same old, we say the largest element in an array after merge. Actually, this idea is the same, right? Yeah, this is the same idea, which we showed it's not right. Because the 214 is 781 is we can add everything together. Holy crap, we can add everything together. I mean, we can add everything together. But how? Well, maybe these two together, that's 71. These two can be added together. That's 117. And 117 plus 97 is 214, which means we can have 214 at here. Oh, and then we can add these three together. Ah, I see. We can add these three together. Oh. So what is... So we want the value on the right hand side as big as we can. All right, as big as we can. So in this case, if we go from right to left, we add this, which is 71. Can go, so we add 71. And then we add, right? And then we can add. Yeah, maybe it's a right to left. We just need to do right to left, right? So yeah, we can do this is 71. Right, this is no, that's not 71. Yes, 71 is 101. Right, this is 117. And 117 add this is 1. No, 214. And then 214 add this is a giant value. So giant. Okay. From right to left. What do you think about that? We go from right to left. We go from right to left, and as long as the value on the right nope, or sum on the right is larger, I still have these things, come on, is larger than any, I don't know. Oh, these are snippet. Then the last element. It's not working. Well, this is working, but we still have these markdown. What the hell is this? Disable snippet. I need to disable snippet. All right, new things to learn. How do I disable snippet when I'm inside this? Yeah, look at this. Lambda is larger than the last element in nums. We can add them together. Yeah, but once we can't, then we just can't. Yes, yes. And if the sum from right to left cannot overpower whatever is the last element in nums, and we have to restart. Okay, so basically we are going to say, sorry, redo this. So res is going to equal to, we want the largest, so res is going to be 0. And then we go right to left, so we have a current, right? And go right to left. In fact, we don't do 0, it's in nums minus 1, right? For I in range len nums, actually minus 2, minus 1, minus 1. Okay, if nums I is smaller or equal to nums, is smaller or equal to current plus equal to nums I, right? And else if nums I is larger than current, then res equal to maximum res current, and current equal to nums I. We restart, and at the end we return res. Whoa, you are kidding me. This one, if we do it this way, it's so much easier than the previous one. Ooh, that is not right. What? It's not. So it becomes 3, and at the end, oh yeah, I know. At the end, I have to go maximum res or current. Okay, we do this. There we go. That's the solution. Now this one is ON. Proudly, this one's ON. There we go. Yeah, I don't know. The first solution was wrong. This is the right one. People say go from right to left. Greedy. You can call this greedy. Ooh, we have issues with LeetCode. Alright, well, I'll let it run. But anyway, that will be it. I said I only want to do 1, but I did 2 again. Alright, anyway, I'll see you guys tomorrow. I think I might do